Now, the new kind of stuff is this. So we say, what's going to happen when you have an x in the function? Okay, what happens when you have an x in a function? Well, we need to get x by itself. That means we need to get rid of log. And how can we get rid of the log? Well, log is a function. To get rid of it, we need to use the inverse. So we need to use an exponential function. So for this particular procedure, we have a name for it. And I haven't heard about this name very often. So I want you to make sure that you know this name. It's called exponentiation, or the verb exponentiate. What it means is this. What it means is that these will become the exponents of, well, in this case, 2. So they become the exponents of 2. That's what we call exponentiation. And why do we do this? Because now they are inverses. They can cancel each other out. So that's why we have x equals 2 to the 5th power, which is 32. Okay? So that's what we call exponentiation. Again, you're making those numbers to be the exponents of an exponential function. And the base of the exponential function is determined by the base of the log. Okay, so that's how we get rid of log. Okay, so now you are learning basically how to detach things. Okay, you're like, oh yeah, I don't want the log. Can you get the log away? And you're like, oh yeah, sure. Let me just go ahead and use the inverse. And we're going to practice quite a few questions on the back. And you can see the pattern right here. So for number 5, we are seeing log base 3 of x is equal to -2. So we need to get rid of log base 3 in order to get x by itself. Now, the worst thing that you would say out loud is this. The worst thing that one can say in this situation is to say, can we go ahead and divide log on both sides? That would be a very terrible thing to say, because if you say dividing log on both sides, then you don't even know log is a function. So again, log is a function. So in order to get rid of log, we will use the process of exponentiation. So therefore, we put it this way. Okay. Now make sure that the number, the base of the exponential function, must be written here, not like here, not like here. It's here. All right. So those numbers again, they are the exponents of 3 in this case, so that they can cancel each other out. So x is equal to 3 to the -2 power, which is 1/9, or 1/9. Okay. So again, exponentiation is the key to remove your log. So let's go ahead and take a look on the right-hand side. There's not a base written here. That means it's a base 10, common log. So if you have to remove this log, then you will have to do exponentiation with a base of 10. Therefore, x equals to 100. Okay, not 20, but 100. Inverse functions cancel each other out. So log function and the exponential functions, well, log function and exponential function, they are inverse of each other. So so when they are being like this, they cancel each other out, or they cancel each other out like this, just like square root and square. Yes. Because it's log base 10. It's common log. With if the log is not, if the base is not shown, it's by default 10. Okay. All right, number 7. Number 7, it's a bit more challenging because you have some more terms right here, but we still have to remove the log. So we will do exponentiation with the base of 16. Okay. So give yourself a little bit of space to write the base of the exponential function. So what's another way to express 16 to the negative 1/2 power? 1/4, because 1/2 power means square root, and square root of 16 is 4. With a negative exponent, you have the reciprocal, so that's 1/4. So 2x minus 1 is equal to 1/4. You add 1 to the other side, it becomes 5/4. And now, this is where I want to take a moment to talk about what to do to get x by itself. There's a simple procedure right here, but some of you did not do well in the last quiz. Okay. Now, people would say, oh, just go ahead and divide by 2. And they would do this, and now they're stuck because you have a complex fraction on the right-hand side. And they are really stuck. So what's another way to say divided by 2? Multiply by 1/2. So this will be a lot easier for you to handle because now you're saying x is equal to 5/8. That's it. Okay, 5/8. And then for number 8, now, I will tell you this. For number 8, I used to get scared a lot by this type of question. A lot. I was like, how am I supposed to do this with 2 logs right here? And there's some other more difficult questions with 3 logs, and I just got so scared about these questions. But then I learned about exponentiation, and the whole thing got a lot easier. So what's the first step? Is to exponentiate both sides with a base of 7. So on the left, you would simply have log base 5 of x. It's equal to 1. Well, you need to get rid of the log base 5, so therefore you will exponentiate again. So x is equal to